Welcome to Brain Vision.
So the trajectory of the moon around the planet is not a perfect circle, it's rather something like an ellipse, like this one. So in this orbit, there are two special distances, the maximum distance between the satellite and the planet, and the minimum distance between the satellite and the planet. Now, remember the following. The gravitational force increases as the distance decreases. Therefore, the gravitational force will be bigger in this point than in this point. So here we have the biggest gravitational force, let me call it FB, while here we have the smallest gravitational force, let me call it Fs. Then the problem says that the gravitational force Fb is 11% bigger than the gravitational force Fs. So Fb is equals to 1.11 times Fs. Now, what is the relation between the maximum and the minimum distances? So, remember the equation for the gravitational force. The magnitude of the gravitational force is equals to the Newton constant times the mass number 1 times the mass number 2 divided by the distance between these masses squared. So, what is the gravitational force at the point FB? It's equals to the Newton constant times the mass of the Earth times the mass of the moon divided by that minimum distance squared. And on the other side, what we have, 1.11 times the magnitude of the smallest gravitational force, which is equals to g times the mass of the Earth times the mass of the moon divided by that maximum radius squared. Note that there are a lot of common terms on both sides, so we have a lot of simplifications. G is the same, the mass of the Earth is the same, and the mass of the moon is the same. So we are left with the following. 1 divided by the minimum radius squared is equals to 1.11 divided by the maximum radius squared. Then we can send the maximum radius squared to the other side, multiplying to get r max squared divided by r min squared is equals to 1.11. Taking the square root of both sides of this equation, we get r max divided by r min is equals to the square root of 1.11, which gives us a ratio of approximately 1.05. So the maximum radius, this one, is only 5% bigger than the minimum radius, this one, in this situation.